Thank you very much, Professor. I think no one in the audience is astonished or surprised by the fruitfulness and especially the innovative approach of your session, because we all know that the expertise that you have, and thank you very much for sharing your knowledge, experience, and exposure, well blended. Nandana is our General Manager in Concrete and Industrial Sales. Engineer Nandana Amrutudua, may I invite you to conduct the Q&A session of today's webinar session. Nandana, over to you.
Thank you, Dishan. Thank you very much, sir, for the detailed presentation you have done. We have quite a few number of questions. So
there are so many questions. Is that right?
Yes, sir.
Yeah.
Yes.
Shall I answer one by one?
Okay, sir. Please.
First one is Mr. Yoga. Yeah, Yoga. Sorry, I can't pronounce it. So is it possible to use shearing spacing proposed for tall buildings here for low rise? Actually, you can use this earthquake resistant detailing and, whether it's tall building or normal building, you can use the same guideline that is already given in the guideline prepared specially with the initiative of Mr. S.A. Karunaratna and Society of Structural Engineers. The second question is, Brian Eric, can you please elaborate the effects of modeling the slabs of finite element modeling? Basically, if you are modeling, when you are modeling, you can either model the slab, presence of the slab as a rigid diaphragm, or else, you can actually model it as a membrane, or else the slab. If you are modeling it as a slab, you have to reduce the stiffness to 30%. Whereas, if you are modeling the slab, you have to reduce the bending stiffness by 30%, up to 30%. Whereas, if you are modeling it as a membrane, no need, because, ETAPS has the facility to model this as a membrane. But if you are using SAP 2000, then you can activate the rigid diaphragm option. Then next one is, sir, what is the impact of not considering more about column changes? Oh yes, column changes, due to different loads. That is actually, you cannot take this effect of axial shortening accurately. It was half calculations, half guesswork. So that's why I said, always when you are modeling, when you are providing the reinforcement in the beams, provide some extra capacity in the span, because if something goes wrong, then the bending moment in the span will increase, but because you have provided some extra reinforcement, the beam will not fail. Sir, what is the impact to the column? Yes, then sir, what are the construction stage analysis factors to be incorporated in the design? Actually, it depends on the aging factors, the way that the concrete strength changes. So the construction stage analysis is actually important only if the structure is consisting of a transfer plate. Otherwise, construction stage analysis is not very important. So basically, my rule is, if there's a transfer plate, due to the construction sequence, the dead load bending moments can increase by about 25 to 30%. So generally what I do is, because transfer plate is such an important key element, I simply increase the bending moment from the static analysis by 50%. And shear forces are increased only by 5 to 10%. I simply increase it by 25% and provide the reinforcement. The reason is, I will never take any risk with transfer plate, because transfer plate is a key element. So key elements must be over designed, and that is one of the reasons could be the reason for the collapse of that Miami building, because the designer has not considered the construction sequence, and because of that he has under-designed the transfer plate. When you under-design the transfer plate, the crack widths can be more, and when the crack widths are more and the building is very close to the sea coast, you can get corrosion, and due to the corrosion of reinforcement, there's a very high chance of building collapsing, like what we have seen in Miami. So, Chatur, the water structures, we are using 35A concrete, so the temperature graph will it will not change because the temperature graph is based on the cement content. It is not based on the grade of concrete, it's based on the cement content, now the cementatious material content. And I strongly recommend you to go through the full paper, then you will understand how it has been written, analyzed. And all the details are given in the paper. And if you need further information, just send me an email. I'll clarify. Or we can have a Zoom meeting and we can clarify. So in case there's a software issue found piling doing testing, so basically you can do grouting. And these days, you don't do normal piling. You have additional. There are so many additional measures that you can take. And if you want to have learn about these things, I strongly recommend you to contact Dr. Nalini Silla. He is one of the experts who has done so much work with the Central Highway project. He has massive experience in all these different methods. So there are so many methods like sonic tubes and so many other techniques. And also now with access engineering, they are one of the researchers at Moratua. They are developing optical fiber-based technology as well. So there's a collaborative project going on with access engineering and Moratua University. So there are so many things happening in the piling sector, so many advances. So I'm not the best person to tell everything. Dr. Nalini Silla is the expert. So I strongly recommend you to contact him. Is it possible for design super tall buildings that have human uniform floor areas? Yes, it's possible. With what I have shown you, now it's possible to have super tall buildings where the size of the building does not change. But we'll have a very strong building at the bottom of part of the building by not having the courtyard, but only the top part of the building. Because of lighting and other ventilation conditions, we can have the courtyard. But again, the courtyard also, because we are having PT slabs and complete rigid diaphragms, all those floors also will be strong. That's what Dr. Dhammika Maharachi told me. He said up to 60 stories building is super strong. And 70 stories also possible with the type of dimensions we considered. But if you are going more, we must go for bundle tubes. That means we must go for bigger footprint and bigger number of bundles, rather than by using one bundle as the way that I have shown you. What I have shown is like one bamboo. Don't go with one bamboo. Go with 4 bamboo or 9 bamboo. That's what he said. And Aravind, it's possible to design super right. Okay, Aravind, I have answered your one. Nimal Ranasinghe, what is the ground acceleration used in Hercules in 1990 as Altair? Actually, we did not worry about earthquakes because we knew there is such a massive building, and the natural period of vibration of that building is 6 seconds. And an earthquake in Sri Lanka will last only 20 seconds, and before the building completes 3 cycles, earthquake will vanish. So earthquake, we knew there's no point in doing earthquake analysis for that building because that's a super strong building with the diagrid. So we did not bother to do that. What are the checks to be done for design of transfer floors and beams, and how to select appropriate depth and width for transfer beam? And so basically transfer beams are, if you are going with transfer beam is subjected to torsion. In torsion, the minimum dimension governs the torsional stress. So because of that, try and make them square. Try and make the beam square. So if the depth of the transfer plate is 1.5 meters, make the width of the beam also 1.5 meters. That is the rule. Is it necessary to check it in pile caps, transfer beams? So pile caps are designed with strut and tie model. So when you design with strut and tie model, you don't have to do any crack width calculations. For the design of basement floor in high-rise buildings, is it okay to connect pile cap without the ground beam with 200? No, actually, using 250 to 300 maybe 300 may be okay, but not 250. but you have to provide double layers of reinforcement, and then you have to have pile cap. And if you think the lengths are too high, then you have better to provide ground beams. But if the pile caps are located close by, then no need to provide ground beams. So that's all up to you. If you think something like 6-7 meters, then 300 meters is too small. Better to go with ground beams. Better to go with ground beams. Only in the middle part, but in the outer periphery, because you are having a peripheral wall, you might not need any additional ground beams. When we model with E-taps, beam moments are significantly differ from manual calculation. Yes, that is because you are using your modeling is not very accurate. So if you want to get the real, because unless you ideal way to model slabs is model it as a membrane rather than as a slab. Rather than using plane stress elements, you define it as a membrane. Then you can avoid most of these huge discrepancies. Sean, sir, let's say that we have column with grade 45 and a pile cap were designed for grade 30. You consider any additional effect of column and pile cap junction? Yes. Actually, you have to be a little careful because, the column size may be 1 meter by 1 meter, the pile may be 1.2 diameter. Then you will find that, although you have, then you can use a pile cap and ensure that the pile cap will do the stress distribution adequately. So although the pile is grade 30 concrete, the pile cap is will ensure that it's okay. But I would suggest that, using something like grade 35 concrete, if you are having 45, to keep the difference between concrete grades only about 10 newtons per meter squared. In that situation, the impact will be very small. If you are using grade 45 for column, I would use grade 35 for pile rather than using 30. So you mentioned reduce the slab thickness up to stiffness of 30%. Why do we need? Yeah, actually, I don't like this, modeling the slab band for reducing it by 30%. I would rather simply model it as a membrane. But that is actually given in the E-taps manual. If you look at the E-taps manual, otherwise, basically slab is a member that is supported by the beam. So slab cannot strengthen the beam. But if you model the slab and the beam together without adjusting the stiffness, then you are saying slab is strengthening the beam. That is a wrong assumption. Well, the basic assumption is slabs are supported by beams, but slabs are not supposed to make the beam stronger. But if you simply model slabs and beams together, then you are saying slabs are stiffening the beam, which is a wrong assumption. Are there any differential effects of the structure due to rotational first mode of the oscillation? Any detrimental effects of rotation? Well, basically, it's better not to have first mode. The third mode should be the ideally torsional mode. You have to actually change the strong elements, and one way or the other make sure the dominant modes are the normal sway modes, not the torsional modes. So I have answered a lot of questions. So I think there's another section. Okay.
Okay, I think with the limited time, Nandana, are we concluding the Q&A session?
Yes, sir. So thank you very much for answering in your usual speed. So thanks again for answering most of the questions. So, due to some
you have requested Mr. Nandan and Dr. Kushan as well. Do you want to give them a chance to make any comment or anything?
Yes, sir, please, because now they are already joined us panelists. So I would like if Mr. Nandana can note about this lecture.
Thank you, Professor. Thank you, Nandana. I think we were listening to a complete design course summary. Like he briefed the whole course within 1 hour. So we are very happy. I think most of our participants acquire a lot of knowledge about high-rise building. Also, I think if they were having any issue about the confidence of design and plan, that was also solved by Professor's speech. I think now a lot of participants are very confident that we as Sri Lankan can do any high-rise building designs without.
Yes. Anything up to 1 kilometer or even more possible.
Yeah, that is important. Thank you.
Fully agreed, Mr. Chandana. Thank you for your kind words. Dr. Chandana, can you...
Dr. Kushan, do you have any comments?
Yeah, sure, sir. And thank you very much, Mr. Nandana, inviting me as a panelist. And thank you very much. And I think Professor Jayasinghe, so you have done a very wonderful speech. And that includes practical aspects, numerical aspects, design aspects. It's a blend of all of the key components to be familiar before you do design a high-rise building. And one of the important factor you may highlighted many times is to find the answer, you must know the answer. I think that is what the professor referred the confidence you gain. Whatever
without that, you can never be confident.
Confident, exactly. To find the answer, you must know the answer. I think in overall summary of the presentations, I would say that you must know the answer to find the answer. I think that is a key message passed to the younger generation by Professor with the great experience. And I would like to give one more message to the younger generations. Like even you develop such a complicated numerical model, as Professor very correctly said, you must know the fundamentals. Right? You must feel the structure. What is the expected level of behavior? So what is the predicted behavior? And then you want to see that behavior in the numerical model, and then only you gain the confidence. That is what I said. You must know the answer to find the answer. Right, and I must thank Professor. I think you have done a very wonderful job, and I think that will be really helpful for the younger generations to build up their careers on seeing your personality. And thank you very much. Thank you very much.
Thank you, Professor. Thank you, Mr. Nandana.
Yes, Dr. Chandana, you want to add a few words about it?
Thank you very much, Mr. Nandana, giving me the opportunity. Sir, thank you very much for this very valuable lecture. Like I have gone back to my final year student days listening to you. And as Dr. Kushan correctly mentioned, you always are pushing us to touch the fundamentals, not to just dumbly like just adding values to the computer and then get the values. So that is very well highlighted here. And then I am really glad that you are being part of, and really proud to say that you are a member of our staff, sir. So thank you very much for this presentation, and please keep up all the good work. Thank you very much.
Thank you, Chandan.
Over to the you.
Okay, thank you very much, Nandana, General Manager of INSEE Concrete and Industrial Sales, for conducting the panel session. I think it is not a surprise, as I said earlier. Also, no one is astonished by the fruitfulness and the innovative approach of Professor Tishan Jayasinghe. And may I invite, before we conclude the session, may I invite Dr. Moza Balbaki, our Head of Products and Solutions Portfolio in Cement, to give away the vote of thanks. Dr. Moza Balbaki, over to you, sir.
Thank you, Tishan. First, really, I would like to thank everyone who attended to this wonderful session. Really, I would like to say that today we had more than 390 participants from the very beginning to the end. And on top of that, I would like really just directly go and thanks really from my deep heart, my gratitude. I don't know how to thank you, Dr. Jayasinghe, for your generosity, for the know-how, for all this really time you have spent to give us this wonderful, really wonderful presentation about what is relevant in tall building. And you make it very clearly what is difference between small building, tall building, and super tall building. What is really important. And also that very often we should go beyond standards. That is definitely very important, especially when we go for designing sometime out of the what I call the boundary, because a super tall building is designing out of the boundary. Therefore, we need to have some time, very good understanding of what structure, how it could behave. This is really very interesting to see that. And even though I know from the material point of view, today, if you want to design a bridge for 50 years, the EN 206 is enough. Okay, but if you want to design a bridge for 100 years and plus, all service life modeling are requesting more. We go beyond this normal standard. And that is very interesting to have heard that. Therefore, thank you so much. Thank you so much also to all the participants. It was really great to have you all again this session. As I said, more than 390 participants from the very beginning. I would like to also thank the panel, our friends, Dr. Chandana, Dr. Dishan, Dr. Kushan. Thank you so much, very much for also your intervention. You know, that was very very great. Thank you for your generosity also. Therefore, of course, we would like really to again have this face-to-face, to be able to meet in person our guest speakers like Professor Tishan Jayasinghe this time. You know, to have this relation, this personal contact, because it's very important, you know, how we can bridge as humans together. But of course, we are having some challenges, and I hope that we will go through these challenges very soon, that we can have again this knowledge sharing session, the I2I knowledge sharing session again here in Palyagoda, where I'm actually now sitting now and talking to you. And I hope soon we will be able to, to have this opportunity again to meet together and have some social activity just after this event. Therefore, we will continue every month, the last Thursday of every month, to have this, this webinar session. And we will do it with our expert, what I call the expert people in the industry, with academia, you know, to bring topics that are relevant to you. And with that, I would like to finish and to say thank you again so much, and hope you are safe with your family. You have to stay strictly safe, of course, and see you next time. Thank you so much. Thank you.
Thank you.
Thank you, Dr. Moza Balbaki, Head of Product Solutions Portfolio in Cement. And thank you again, Professor Tishan Jayasinghe, delivering the super session on optimized and sustainable super tall buildings. Ladies and gentlemen, friends, let's catch up again with the 29th knowledge sharing session. Until then, be safe. Good night.
Thank you.